magnetic fields. The purpose of this lab was to find the magnetic field of a bar magnet and compare the observed and predicted magnetic fields. Useful formulas were the Biot-Savart law and its various renditions for bar magnets, the magnetic constant, the magnetic dipole moment, the linearization that we use for the graph, the distance dependency, and the results were that the observed and predicted magnetic fields were relatively close in magnitude. So the overview of the system was the bar magnet and the surroundings were Earth and anything else that could have impacted the magnetometer. The initial conditions was a bar magnet laying on a table with a meter stick directly adjacent to it. And then the required R&Ms were a bar magnet, a smartphone, a meter stick, a magnetometer app, a ruler, some tape, and Excel. And the instructions for the lab were find magnetic norths, then find BY, BNet, locate the sensor inside the phone, move the phone until you find a distance at which BX, or the magnitude of BX, is 20. Record BX, repeat twice, do the same for values of 70, 120, 170, and 220. Then move the phone until you find the distance at which the magnitude of BNet is 100. Record the Y value, then the X, Y, Z values of B, and compensate for Earth's magnetic field and repeat twice. And then this is how you would go about doing that. So for the data and results, we got this linearization here. This slope gives you the n value, and this intercept gives you the natural log of k. K itself is equal to 1.54 times e to the negative 6, and then the u value, or the dipole moment, was 7.729. And then there are some bits of data here that we'll come back to in a minute. So for the coding, this here is the formula that we're using in the code. It's the same as the magnetic field off axis all the way back up here. And then there are a whole bunch of arrows and observation locations. And then let's see. Here is the magnetic dipole moment. Here is the observed average distance for off-axis field. And then here is the computer's predicted distance, which is pretty close. And then here is the predicted B at distance D, which is 7.04 times e to the negative fifth, which is a bit bigger than the observed, which was 6.48 times e to the negative fifth. And then what if magnetic north had not been compensated for? It would have thrown off all the observed values as the magnetic fields from Earth and magnets mixed in a way that we couldn't have predicted, making it significantly harder to extract the usable values. And then if two identical magnets had been stuck end to end, the observed magnetic field would greatly increase in strength, meaning the observed distances would shrink and the distance dependence would increase in magnitude.